In this video, we are going to look at the question 6s for the CSEC math exam for the years June 2022 to 2019. So here we have our first question. This is question 6 for June 2022. The diagram below shows the solid made from a semicircular cylindrical base. So that's the semicircular cylindrical base down here, with a rectangular prism, which is this thing on top here, above it. The diagram of the cylindrical base and the width of the rectangular prism are 4 centimeters each. So this is the diameter here of the cylindrical base, which is 4 centimeters, as well as the width of the triangular prism, which will also be this 4 centimeters. So for our first question, we want to calculate the total surface area of the solid. Now, what we have to do is get the total surface area of the cylindrical base, and we have the surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now, this here would be, the cylindrical base would be half of a cylinder. So you can work out this formula here, and whatever answer you get, let's find half of it, and that would be the surface area of the semi-cylinder. Now, for the rectangular prism, we have a 4 by 12 rectangle on top here. This would be a 4 by 4 square on the ends, and this would be a 12 by 4 rectangle on the sides. So here I draw the net for the rectangular prism. We have our 3 12 by 4 rectangles here. See, 12 by 4. This will be 4 here by 12, 4 by 12, so 3 of them. All right, so what you notice about this is 12 centimeters long, and the 3 rectangles stacked together, 4 plus 4 plus 4 is also 12. So this will be a 12 by 12 square, this whole thing here. And then, of course, we have our 4 by 4 squares on either side. So my surface area of the rectangular prism would be the area of this big square here, which is 12 by 12. So I'll have 12 by 12 plus the area of these 2 small squares, which is 4 by 4. So that'll be 4 by 4 plus 4 by 4. Or I can simply say 2 times 4 by 4. All right, so again, the 12 by 12 is this 12 here times 4 plus 4 plus 4, which is 12. So 12 by 12, this whole thing is a square. And then these 2 4 by 4 squares. And that will be the surface area of your rectangular prism. So 12 by 12 is 144. And 4 by 4 is 16. And we would get 176 centimeters squared. Now this is just the surface area of the rectangular prism. Now for the surface area of the semi-cylinder, remember we're going to use this formula here. Now we know the diameter is 4 centimeters, so we know the radius is going to be 2 centimeters. Alright, so I just put this here to show you that the diameter here is 4 centimeters, and therefore my radius here is 2 centimeters. Now the height for the cylinder would be this length here, which will be the length of the rectangle, which is 12 centimeters. So I put this 12 centimeters here, so this will represent the height of the semi-cylinder. So now that we know what is R, being 2 centimeters, and h being 12 centimeters, let's work out the area of the semi-cylinder. Now, seeing that the area of the cylinder is 2 pi r squared plus 2 pi r h, what I'll do is just find half of this one time by putting a half in front. So a half times, so open brackets, 2 pi r squared plus 2 pi r h. Now, when you multiply half times 2 pi r squared, what you'll get is a half of 2, which is 1, so you just get pi r squared. And when you multiply half by 2 pi r h, a half by 2 would give you 1, so you just end up with pi r h. So the formula becomes, when you multiply the half by this, we're going to get pi r squared plus a half times this will give us pi r h. So now we can just put in those values. I'll leave the pi as pi because I'll use the pi button on the calculator. R squared, we have 2 squared plus pi times r, which is 2, times h, which is 12. So on my calculator, I'll press my pi button, which is pi, open brackets, 2, close brackets, squared. That's all I have it there. Plus pi, open brackets, 2, close brackets, open brackets, 12. So you multiply in there and press equal, and I get 28 pi. Just convert that into a decimal, which is 87.96. So I'll have 87.96 centimeters squared. So now the total surface area of this solid would be to add this 87.96 to this 176 centimeters squared. All right, so here we have that the total surface area of the solid will be the 176 plus the 87.96, and we get 263.96 centimeters squared. And of course, that's approximated to 2 decimal places. Now for part B, we want to calculate the volume of the solid. So that will be the volume of this rectangular prism, which is length by breadth by height. So 12 by this 4 times the height of 4. So that's 12 by 4 by 4 with the volume of this rectangular prism. And then the volume of the semi-cylinder, the volume of a cylinder is pi r squared h. So let's find half of that, and that will be the volume of the semi-cylinder. So I'll do it in 2 parts. All right, so I have the volume of the rectangular prism is equal to length by breadth by height. So the length is 12, the breadth is, or width is 4, and the height is also 4. So that will give you 12 by 4 by 4, which is 192. So that's 192 centimeters cubed, because this is volume now. So centimeters squared is for area, centimeters cubed, that's volume. So the volume of a cylinder is equal to pi r squared h. So the volume of the semi-cylinder is going to be a half times pi r squared h. Okay? So now let's put those values in. Half pi, and the radius, remember the radius was 2 centimeters, so that's 2 squared, and the height was 12. All right, so if you go to the calculator, we can put in the half. You can use 0.5 for half, or use the fraction button and put a half. I use fraction button here, so 1 over 2, so that's a half. Use the pi button for pi, and open brackets 2, close brackets squared, and then the 12. So open brackets 12, close brackets, just like that. And we get 24 pi. Convert that to decimal, that's 75.39. This 8 will cause this 9 to go up by 1, which will cause this 3 to go up by 1, so that's 75.4. So we're going to have 75.4 centimeters cubed. So my volume of this solid will be equal to the 192 centimeters cubed plus the 75.4 centimeters cubed, which is equal to 267.4 centimeters cubed. So part C of this question now, we have the solid is made from gold. 1 cubic centimeter of gold has a mass of 19.3 grams. The cost of 1 gram of gold is $42.62. We want to calculate the cost of the gold used to make the solid. Now remember here, we worked out the volume of the solid to be 267.4 centimeters cubed. So I'm going to write the volume of the solid is equal to 267.4 centimeters cubed. So if 1 cubic centimeter of gold has a mass of 19.3, so then this 267.4 centimeters cubed of gold will have a mass of, well, you have to multiply this by 19.3. So I'm going to put the mass of the solid in gold is equal to 267.4 multiplied by 19.3. And that'll be equal to 5,160.82 grams. So now, if the cost of 1 gram of gold is $42.62, you just have to take this $42.62 and multiply it by this 5,160.82. So I'm going to have the cost of the gold to make solid, and that'll equal to the $42.62 multiplied by the 5,160.82. And that'll be equal to, we're going to have 219,954 and 15 cents. And this will be question 6 for June 2022 completed. Now let's move on to question 6 for June 2021. So here we have Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick, as shown in the diagram below. The troughs are rectangular based, open at the top, and have external dimensions of 300 centimeters by 190 centimeters by 160 centimeters. So here we can see the external dimensions, 300 by 190 by 160 centimeters. We can see that the wood is 5 centimeters thick here, and it's open at the top. Now we want to show by calculation that the internal capacity, which is the volume of the trough, is this 8,091,000 centimeters cube. Now what we have to remember here is that these are the external dimensions. So we know a rectangular prism, the volume is length by breadth by height, or length by width by height. But we're not going to use the 300 by 190 by 160 because that's the external, okay, dimensions. The internal dimensions, because of this 5 centimeters thickness, the if you want to consider this to be length, would be 5 centimeters over each edge, which would be a total of 10 centimeters. So the internal length would be 300 take away 10, which would be 290. Now they said that the trough is open at the top. They never said nothing about open at the base as well. So you're going to assume that the base has a piece of wood that is 5 centimeters thick as well. So the height of 160, all right, we'll take 5 away from that, and that'll be 155 for the internal height. And likewise, this 190, we'll have to take away 5 on either end, which is a total of 10. So that'll be 180 centimeters width. So for my internal dimensions, I'm going to have the length, which is equal to 300 take away 10, as we discussed, which will be 290 centimeters. I'm going to have that the width would be 190 take away 10, which would be 180. I'm going to have the height, which would just be the 160 take away 5, which is 155. So now that I know the internal dimensions for the length, width, and height, the volume is easy to calculate. Just length by width by height. So my volume will be equal to length by width by height, or length by breadth by height. You know, breadth, width, interchangeable. All right, so that'll be 290 times 180 times 155. And let's see what we get. All right, so we're going to have 290 times 180 times 155. I can see we get that 8,091,000 centimeters cube. All right, so that's 8,091,000 centimeters cube. Now for part B of this question, we want to calculate the volume of wood needed to make this trough. Now we already calculated the internal volume. If we were to calculate the external volume and subtract it from the internal volume, the remainder would be the volume of wood needed to make the trough. So what we need to calculate now is the external volume of the trough. So I'm going to have the external volume is equal to length by width by height. And that length will be 300 times the width, which is 190, times the height, which is 160. And that will be equal to, all right, 300 times 190 times 160. All right, you're going to get a big number there. 9,120,000. All right, so 9,120,000 centimeters cube. Now we're going to recall that the internal volume was this 8,091,000. All right, so my internal volume was equal to 8,091,000. So the volume of wood needed would be equal to the 9,120,000 take away the 8,091,000. All right, so seeing that I have the 9,120,000 already up on the calculator, let's use that back and let's take away the 8,091,000. And I'll get 1,029,000. All right, so that's 1,029,000 centimeters cubed. So now for part C, we have that Farmer Brown must paint the internal surface of the trough. Given that 1 gallon of paint covers approximately 280,000 centimeters squared of surface, determine the total amount in liters that is needed to paint the internal surface of the trough. And we have that 1 gallon is approximately 3.79 liters. Now, what we have to do here, we have the surface area that the 1 gallon of paint covers. So before we do anything, we need to find out what is the surface area of the internal walls. Now remember, we calculated the internal volume, and to do that, we had the dimensions for the inside. So the length was, instead of 300, you take away 5 on either side, which would be 10. So we had 290 as the length. We had 180 as this width. And we had 155 as the height. So remember, for the height, we'd just be subtracting 5 because of the board at the base. Okay, so 5 take away 160 is 155. So we have the board at the base, which will be a rectangle. So I'm going to have the area of the board at the base. I'm just going to put internal base. Okay, I'm going to put length times width. So the length would be 300, take away 10, which is 290. Times the width, which would be this 190, take away 10 as well, which would be 180. And we will get 52,200 centimeters squared. Now, just looking externally at the walls, we have this one that is 300 by 160. And then we have this one which is 190 by 160. So this wall that is 300 by 160, we have that twice because that'll be the front wall and the back wall. And this wall that is 190 by 160 will be twice because this would be the two side walls. Now, remember, that's just externally I'm looking. So internally, this 300 will be what? 290 times 155. So I'm going to have that the internal surface area of the walls would be equal to 2 times, because these two walls are the same, and this will be 290 by 155 internally. All right, so 290 times 155 plus these two side walls are the same, and that will be, so this is 190, so take away 10 will be 180 times the 155. So you're going to have 2 times 180 times 155. So this here would be the front and back wall, and this here will be the two side walls. So we have 2 times, all right, 290 times 155 is 44,950. And we have 2 times 180 by 155, that's 27,900. So 2 times 44,950 is 89,900. And 2 times 27,900 is 55,800. We add that up, and we get 145,700. And that is centimeters squared. So all we need to do is add the internal surface area of the walls to the internal surface area of the base. And that would be, my total internal surface area would be the 52,200 plus the 145,700. And that will give 197,900 centimeters squared. So now that we know the internal surface area to be painted, we know that 1 gallon of paint will give us approximately 280,000 centimeters squared of surface. So I'm going to have the paint needed in gallons will be equal to this 197,900 divided by 280,000. All right, and if I'm going to go to 2 decimal places, this will be 0.71 gallons. So now, seeing that 1 gallon is approximately 3.79 liters, we'll take this number of 0.71 gallons and multiply it by 3.79 liters to get the amount of paint in liters. So the paint needed in liters is equal to 0.71 multiplied by 3.79, which is equal to 2.69 liters. So he needs 2.69 liters of paint to paint the internal surface of the trough. So moving on to question 6 for June 2019, we have the scale on a map is 1 to 25,000. Now this just means that every 1 unit on the map is 25,000 actual distance. So 1 centimeter on the map will be 25,000 centimeters actual distance. If you had 1 meter on the map, it'll be 25,000 meters actual distance. So that's how it's operating. So before we get into the question, things you need to know. We know that 1 meter is equal to 100 centimeters. And we know that 1 kilometer is equal to 1,000 meters. So what we have is 100 centimeters to make up 1 meter, and then 1,000 of those meters to make up 1 kilometer. So 1 kilometer is going to be equal to 1,000 times 100 centimeters. So 1 kilometer is equal to 100 or 1,000 times 100 centimeters, which is just 100,000 cm. So when we have this question as what is 0.5 centimeters on the map, what we have to know is that 1 cm on the map is equal to 25,000 cm actual distance. Now let's convert this to kilometers. So now to convert this 25,000 centimeters in terms of kilometers, we'll have to divide this 25,000 by 100,000. So 1 cm on map is equal to 25,000 divided by the 100,000 kilometers actual distance. So 1 cm on a map is equal to, if you break this down, the zeros will cancel. So you end up with 25 over 100, which is just a quarter. So 1/4 kilometers actual distance. All right, so 0.5 cm on the map, which is just half of 1. All right, multiplying 1 by half would just be multiplying by half by a quarter, or a quarter times 0.5. All right, so now you understand that 0.5 is a half, so a quarter times that, this be a quarter times a half. So a quarter times a half, which is simply 4 by 2 is 8, so that's 1/8. 1/8 kilometers. All right, so if you didn't want to do it that way, you could say the 1 centimeters on the map is equal to, when you divide these two things, you get 0.25. All right, kilometers actual distance. So 0.5 centimeters on map would be equal to the 0.25 multiplied by 0.5, which is equal to 0.125 kilometers actual distance. So now for part 2 of this question, I'm going to calculate the actual area in kilometers squared represented by 2.25 centimeters squared on the map. So what we established previously is that this 1 centimeter, 1 centimeter is equal to a quarter kilometers actual distance, which means 1 centimeter on the map is equivalent to 0.25 kilometers actual distance. So I'm just going to put that back. All right, so we're going to have 1 centimeters on the map is equal to 0.25 kilometers actual distance. Now, we're going to square both sides, so we know whenever to one side the equal sign, do to the other side to keep things balanced. So 1 cm squared, 0.25 kilometers squared. So that's going to give 1 squared, cm squared, lows indices. So 0.25 squared kilometers squared. So 1 squared is 1. So 1 cm squared is equal to and 0.25 squared is equal to 0.0625. All right, and that'll be kilometers squared. So now that we know what 1 centimeter squared on a map represents in actual distance, we can find out what is 2.25 centimeters squared by multiplying both sides by 2.25. So we're going to have the 1 cm squared by 2.25, and that'll be equal to the 0.0625 kilometers squared by 2.25. So 1 times anything will give back the same thing. So you get back 2.25 centimeters squared. And now you're going to multiply 0.0625 by 2.25. And to 3 significant figures, you can get 0.141 kilometers squared. So I'm going to write that 2.25 centimeters squared on map is equal to 0.141 kilometers squared actual distance. All right, so moving on to part B of this question, we have the diagram below, not drawn to scale, shows the cross-section of 2 cylindrical jars, jar X and jar Y. So this is jar X here, and this is jar Y. The diameters of jar X and jar Y are 3D centimeters and D centimeters. So this is the diameter here for jar X, 3D, and D is the diameter for jar Y. Now we're saying that initially jar Y is empty. As you can see, jar Y is empty here, and jar X contains water to a height of 4 centimeters. So this is water here with a height of 4 centimeters in jar X. Now we want to determine in terms of pi and D the volume of water in jar X. So we know this is a cylinder, and the volume of a cylinder is pi r squared h. Okay. So first I'm going to write volume of cylinder is equal to pi r squared h. So we're going to have 4 jar X. We're going to add the height of water is equal to 4 centimeters. We're going to have the diameter is equal to 3D. Therefore, the radius is equal to half of that, which is 3D over 2. All right, centimeters. Centimeters here. So the volume of water is equal to pi r squared h. And remember writing this in terms of pi. So we leave in pi as pi. The radius would be the 3d over 2 squared, and h would be 4. So using our laws of indices, we have square the d, the 3, and the 2. All right, so we have pi times 3 squared, which is 9, d squared over 2 squared, which is 4. All right, times 4. So what will happen is these 4s will cancel because this is 4 over 1, and this 4 on the denominator here will cancel with this 4. All right, so cancel, cancel. And what you remain with is 9d squared multiplied by pi. So you're going to have 9d squared times pi centimeters cube. So for part 2 of this question, we have if all the water of jar X is now poured into jar Y, calculate the height it will reach. Now remember, we just calculated the volume of water in jar X to be 9d squared pi, all right, centimeters cube. So I'm going to put volume of water in jar X is equal to 9 pi d squared centimeters cube. So now for jar Y, all right, we're going to have the diameter is equal to d. So that means the radius is equal to divide diameter by 2. So d over 2. All right, and we're going to let the height be h. All right, that's because we don't know what the height is. Okay. All right, so volume of water in jar Y is equal to pi r squared h. So we leave in h as the height, we leave in pi as well, and the only thing we replace in here is the radius with d over 2. So that's d over 2 squared. So remember laws of indices now, we square in the d and the 2, so we're going to have d squared over 4. So I'm going to have pi times d squared over 2 squared, which is 4, times h. Now multiplying across, this is pi over 1, so pi by d squared by h. So that's pi d squared h over 4. And that's the volume of the water in jar Y. All right, so let's put my centimeters cube here. So now to find out the height, which is h, we have to put the volume of water in jar Y must be equal to the volume of water in jar X. So we have to put this equal to this, and then we're going to solve for h. So I'm going to have the volume of water in jar Y must be equal to the volume of water in jar X. So here we have the volume of water in jar Y is pi d squared h over 4. So that's pi d squared h over 4 is equal to, and the volume of water in jar X is 9 pi d squared. All right, so that's equal to 9 pi d squared. All right, so just looking at this, we could see that both sides have pi, which will cancel off. Both sides have d squared, which will cancel off. All right, so what we remain with is h over 4 is equal to 9. All right, so we could cross multiply there. H over 4 is equal to 9 over 1. We multiply h by 1 and we get h. I multiply 4 by 9 and get 36. So my height of water in jar Y is equal to 36 centimeters. And that's it for this video.